Hello, and welcome to this k-means clustering tutorial in Python and R. Uh, we are Conwell Consulting, and we have been tasked with deciding which language is better for k-means clustering, Python and R, by our clients, Google. K-means clustering applies to Google because they can use it to cluster their customers, their clients, web viewers, whatever, into different groups so that they can target them with different ads, provide different search results, and things like that. So this is an important process for them. They want to know which one they should be using for the best results. Okay, to start off, we've got code in Python on the left, R on the right, and we're using a data set from an online retail company. The two important columns in this data set that we'll be focusing on are average time spent on the site and average amount spent on the site, per transaction, per purchase. So knowing that, we'll jump right into the code. On the left here, we've got Python, and we'll start by importing the libraries that we'll need to use as well as the data set, which we just talked about. Then we'll use the elbow method in order to determine the correct number of clusters to separate these customers into. And what we see here is it creates a nice line graph here. And when it starts to even out, which is around 6 clusters, we know that is the correct number of clusters to use in our k-means clustering algorithm in the next step. So after that, we'll go down here. We'll use our k-means algorithm. See this here, 6 clusters. We got that from the line graph right above. And we'll run this. And then we will visualize the k-means clustering algorithm here with this scatter plot. And we can see down at the bottom, these are our 6 different clusters. We've given them each names based on their characteristics of the customers in there. You can change the names afterwards. Here are all the names. So what is produced by Python is a very presentable cluster chart with labels, a legend, the centroids, which are these yellow marks, so you know where the center of the clusters are, and it's very easy to distinguish, and you could present this in a meeting right away, and you could get your point across. Now let's do the same thing in R and compare the results. So the first step is importing the libraries, but there are no libraries to import in R. There were a few in Python, I believe 3. Next is import the data set, same as before, and then the elbow method, which should produce the exact same graph as before. So let's do that. And here we are, and it comes to 6, just as before, just like in Python. Next, we will use the k-means algorithm with 6 clusters, which we've just determined. And we will visualize it down in this next block here. And this is the cluster plot we end up with. Wow, we can see it is quite different. First of all, it's just much messier to look at than the cluster produced on Python. Second of all, there's no labels. We're not labeling our different clusters to be able to separate them by what we think they are. So seeing this, we can say that Python, we can take the output and we can present it in a boardroom immediately. We can use this to convince someone of something or to convey information, whereas the cluster plot on the right, likely we would need to spruce it up, make it look a little nicer before we showed it to anyone. So based on that, our team Conwell Consulting, came up with these scores for Python and R regarding k-means clustering. Code volume and easy use. Here, Python is a little lower just because Python takes more lines of code to create an output. That being said, the output is nicer, which we will get into later. Popularity in libraries. Both languages are popular with tons of community support. Python is growing more than R currently, but as far as what you'll need to do for k-means clustering, both are more than sufficient. Next, execution, performance, and output. Right here, Python has a huge lead over R, and that is based almost 100% on the output we saw at the end here. Clearly, Python has a much more appealing output than R. And then the next two, scalability and transferability and training and testing, both get a 5. Both can be exported effortlessly, and both are very easy to learn, to pick up. You can learn them very quickly, teach them to someone else, and get into clustering as soon as possible. So with that, our final recommendation is Python over R. Python is easy to use, does not take many lines of code, even though it is slightly more than R, and it creates a beautiful and customizable cluster plot of your clients so that you can get quick into the analysis of your clients. So with that being said, this is our recommendation for k-means clustering with Python and R. We would pick Python. Thank you for viewing this video.